Hi everyone, welcome back to another video today. And it has been around a week. Yeah, been quite some time since I last done a video. So anyway, today let's resume with alkanes. And today I'll be going through specifically about the reaction of alkanes. Yeah, so for today I'll be going through three different parts: production of alkanes from alkenes, and then free radical substitutions (FRS). And this is actually the most important part for all the reactions that alkanes undergo. And then next is combustion, which I have covered briefly under mole concept. And just gonna cover one more, which is why alkanes are generally very unreactive. Yeah, so this not really a learning objective, but when I look at the SCAB learning outcomes, but a lot of schools include it, so I figured I should just go through it as well. Okay, so today, first for the production of alkanes from alkenes. So let's say you have an alkenes, uh, something simple like 18 maybe. Oh, sorry, like that. And then you want to make an alkane into an ethane. Sorry. Okay, so CH. So what you are doing here is you are essentially just uh, breaking up this pi bond here and form two more hydrogen here to the alkene. So usually there are two reaction condition for this. So for the first one is you can use nickel catalyst with hydrogen gas, and then but for nickel catalyst you have to use heat. So you have to heat this reaction up for it to happen. The other condition that you can use is either platinum or palladium catalyst and hydrogen gas. And then for this case, you don't need heat. So you only need room temperature, yeah, for the reaction to occur. So that's all there is for this learning objective. And the next is the most important one, is FRS. So the FRS is essentially what you're doing is you take an alkane. So let's say I have methane here, and then you react it with halogens. So either CO2 or Br2, and then you will form a halogenoalkane. Either chlorine or bromine, and then you produce a HCl or HBr as a gas, as a byproduct. So this reaction, the condition that it occurs is under UV light. Okay, so you guys have to know the mechanism for this. So it proceeds via a three steps process. The first step is called the initiation step, whereby you start the reaction. So first, let's say you have CO2, and then if you then you radiate it with UV light. What happens here is that it will undergo homolytic fission, which means that the electrons is split equally between these two. Electrons split equally. And then you form two chlorine radicals. So what happened here is that if I were to draw a dot and cross diagram, so you know that within one covalent bond there are two electrons here. And then what happens is that one of these electron will go to this chlorine, and the other electron will go to the other chlorine. And then what you get is a chlorine with one singly bonded electrons. So it will have 7 valence electron, and this single electron here is basically what this dot is representing. So you form two chlorine radicals. Okay, so the next step that it undergoes is called the propagation step. So what happens here is that there are two smaller steps happen. So for the first step is you have your alkane. It will react with one of the chlorine radicals. So what happens now is this CH bond will undergo homolytic fission. So one electron will go to the carbon, then one electron will react with the chlorine radicals. So the product that you get is a CH3 radicals plus HCl, and this HCl right here is actually your byproduct up here. Okay, and then the next step, the B step, is whereby you form your product. So your wanted product, the halogenal alkane. So your CH3 radicals, if you collide with another CCl2, and then single reaction happen, if you break homolytically, then the radical combine, and then you will get your desired product of CH3Cl, and then you get other chlorine radicals. And why this is called propagation is that you see in the B step here, these chlorine radicals can continue and take part in step A again. So what happens is that step A happens, then B, and then A can happen again due to these chlorine radicals that form in B, and then it can goes back to A, and the reaction can keep repeating A B non-stop. Yeah, and radicals are very reactive, so the reaction will happen very fast, and you only need a small amount of chlorine radicals for this to keep happening. Okay, so the final step that we have is the termination step, whereby you end the reaction, you stop the reaction. So you basically just have to use any two radicals, and they collide with each other to form a non-radicals molecule. So such as two chlorine radicals that collide to form Cl2, or you can even have two CH3 radicals. They clash with each other to form C2H6. Or you can even form your product by using H3C radicals colliding with Cl radicals to form your CH3Cl. And for a lot of schools, what they enforce is that you write minimum two reactions for termination steps. So just pick any of the two, just pick two out of the three here, and you are good to go. Okay, so this is the most important reaction for the FRS for the A-level syllabus. Yeah. So the next one is simply combustion. And here you have two scenarios. First, you have complete combustion, and then you have incomplete combustion. So for complete combustion, what you get is you have an alkane, and then when you burn it in oxygen gas in excess, what you get is carbon dioxide plus water. Yeah. So for an example, let's say I have a methane CH4 plus oxygen gas. I form CO2 H2O, and then I simply just have to balance this equation. So the carbon is the same, 1, then now I have to balance hydrogen, 2, 4, the same, 2, 2, so here just 2 oxygen. But for incomplete, you have an alkane, then plus oxygen in limited, you produce a carbon monoxide, and then you will still get some water. So what happens is you have a CH4 plus oxygen, and then I guess CO instead of a CH2, CO2 instead of a CO2, sorry. And then now I just balance equations like that. Yep. So I've already covered this under more concept, my more concept video. So please take a look at it if you would like. And it's just simply remembering which reaction it is. Is it complete or incomplete combustion? Yeah. So for the next one, just to touch on it lightly for why uh sorry about that, for why alkanes are unreactive. So there are the first one is that CC and CH bonds are very strong bonds. So uh they don't they don't break easily. Yep. Mm. Like the activation energy is quite high, is very high, so they don't break easily when it's reacted with nucleophile or electrophile. So I have a data booklet with me, I can show you. So for C single C bond, the energy is 350 kilojoule to break 1 mole of C double C. Then for CH is 410 kilojoule per mole. But if you compare against other bonds such as CCl is 340, is lower, CBr 280. Then compare with other groups such as PP, SiO is much lower in energy. So C single bond C and C single bond H has very high kilojoule per mole to break 1 mole of such bond. So it does not break easily. And then second point is that there carbon and hydrogens are relatively similar in terms of electronegativity. So this make them not susceptible to nucleophiles and electrophiles attack. Yep. So when you compare CC and CH versus other functional group like let's say ketone, right? This carbon in ketone is more likely to be attacked due to this electronegative oxygen. But this is not the case for alkane because electronegativity are most likely similar. So the bond is actually non-polar, so it does not get attacked very easily. And the third reason is that all orbitals of carbons are used to form bonds in alkanes. So what happens is that because in alkane it has a tetrahedral structure and this carbon right here is sp3 hybridized, so it does not have any empty energetically accessible orbitals to form lone pairs to form lone pairs or to accept a lone electron. Hence, it does not form any bonds with other attacking species. Yeah, so this is all that really is to reactions with alkanes, and alkane is not really a complex molecule per se. So let's say you are doing some reaction mechanism and you see some weird structure like that or like that, like that. You can simply just focus on the other functional group and completely ignore all the alkane chain in between because the alkane chains are unlikely to undergo any reaction unless there's some UV light involved in it. Yeah, so really thank you for watching till this far and I hope this has been helpful and see you guys next